Greetings to all of you. In today's session, we are going to discuss about intermediate level chemistry. Will be fetching for your international entrance exam or any competitive exam you're aspiring for. National level JE Advanced and JE Mains examination for engineering stream, IITs and NITs, you are preparing for that one. And next is about NEET chemistry for medical entrance examination throughout India. Telangana and Andhra Pradesh MSET examination for engineering entrance into various technical streams. And also for competitive exam, you're aspiring for any competitive exam. In that also the questions whichever coming from what general science will be the part of this session, right? Let's enter into our today's session. Explain the name of the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. Here is the compound which is said to be a cyclic ring and where you can find chloro, bromo and methyl. Ball and stick model is also provided for your convenience. If this is the case, then how can we assign the numbering? And for your convenience, numbering is already given. And how can we designate the compound as per the IUPAC protocol? In order to give the name, here, first carbon is having chloro, second carbon bromo, third carbon methyl, fourth, fifth, this is the way a cyclic ring system will be there, right? So whenever this is the case, we have to go for alphabetical ordering, though first carbon is having chloro, but in order to write, we will start with the 2 bromo. Later on, 1 chloro will be there and 3 methyl will be there. Till here, we followed the alphabetical rule. And the next, in order to pronounce this, we have to give cyclo. Being it is a ring system, cyclo will come and 5 carbon as a parent chain, so that cyclopentane is the skeletal compound over here. This is the way 2 bromo, 1 chloro, 3 methyl cyclopentane is the complete norm as per the IUPAC protocol for the given organic compound. Move on to question number 2, Cambridge Assessment International Education. From the source, the question was retrieved. Here is the graphical representation with the 2 coordinated system. On the x coordinate, we have progress of the reaction, how it is proceeding, and energy of the reactants products, how they are changing during the reaction time. This is mentioned in the y coordinate. If this is the case, reactants are at the bottom source, and as we are moving, so as the reaction progressing, what happens, they are reaching a certain extent of intermediate stage, which is called transition state. And later on, they finally converted into a product. If you observe, there is a difference in the energy levels. Reactants of lower energy on this y coordinate. And if you observe the products, they are of high energy. Compared to reactants, products of high energy, we need to notice. In this case, what will be the change in the chemical reaction? What is the correct representation for this one? Heat released during the reaction or absorbed? We need to identify. It is a combustion reaction. If, in order to explain the combustion, there is a kind of burning in the presence of oxygen required. Nowhere it is mentioned, so that we can't go with. It is an endothermic reaction. This might be correct. We will explain about this. The temperature increases. Temperature, it is not the matter of temperature. It's in terms of energy we are seeing about, and during the progress of the reaction, how reactant will be converted into product in the energy transformation. That part we need to focus on. So that, let's see, reactants of lower energy, product of higher energy, there is no question of release of heat, because heat not in excess quantity with the products. Product itself is the excess in energy. That's why here 2 kind of graphical representation, reactants of higher energy and product of lower energy. Reactants of lower energy to product of higher energy, both the complexations you can notice. If products of lower energy compared to reactant, that is said to be a exothermic, heat coming out, heat released during the system, which is called exothermic. This is not the case we observed. This is the one, product of higher energy. Product of higher energy requires external energy to be consumed, that is said to be endothermic reaction, heat absorbed during the reaction, right? Here you can clearly notice energy absorbed over there. Reactants reaching the higher point, tip point, we can say. The tip point is called activation energy. After reaching this one, again, they slowly converted into product side. And the product is of higher energy compared to reactant in the endothermic reaction. That is exactly the case what we seen in the question number 2. So that for question number 2, option number C will be the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2020 question paper, paper 2 question it will be. And it is the kind of some numerical problem we can see. An acidified solution of potassium chromate will be taken, was layered with the equal volume of amyl alcohol when it was shaken after addition of 1 ml of 3% hydrogen peroxide. A blue alcohol layer was formed. The blue color is due to the formation of chromium 6 compound X. We have to identify this. What is the number of oxygen atoms bonded to the chromium through only single bonds in the molecule of X? What we are seeing, potassium chromate was taken and amyl alcohol will be added. Whenever amyl alcohol is added to the potassium chromate, what happens? Another oxidizing agent H2O2 will be added. A blue color layer is obtained. That blue color is because of what? This chromium, potassium chromate now turned into potassium, another new compound will be formed. In that new compound, what will be the geometry and what will be the location of oxygens with the singly bonded with the central metal? The set of single bonded oxygens are required to be predicted. For that purpose, K2CrO4 is called potassium chromate. K2Cr2O7 is called potassium dichromate. Here K2CrO4 called potassium chromate. Under acidified conditions, we need to treat with hydrogen peroxide. Being it is the kind of what we can say oxidizing agent, so that K2CrO4 now turned into CrO5. CrO5 is the kind of oxidized form. Here, 4 oxygens to 5 oxygens, obviously, addition of oxygen is said to be a kind of oxidation. So that oxidation of this one is carried. Whenever it got oxidized, it turned into a deep blue color solution. CrO5 is a kind of deep blue, intense blue in color. That CrO5 can be represented with chromium with the doubly bonded oxygen and a singly bonded oxygen with 2 peroxy linkages. And they're asking for singly bonded oxygens with the central chromium. How many set of oxygens are there? In order to explain, one you can see, second one, third, and fourth. Four oxygens are singly bonded with the chromium, so that we can see the number of oxygens singly bonded with chromium are 4. This is the answer. 4 is the correct answer. What you can clearly see over here, where 2 peroxy bonds and 1 carbonylic linkage is there around the central chromium. And chromium is accompanied by plus 6 oxidation state over here. Why can we say plus 6? How can we answer this one? Actually, if without knowing this geometry, without knowing its geometry, if you see this, as per the general analogy, what we can notice, so 5 oxygens are there. Each oxygen will contribute -2, so that we can say 10. So each oxygen is 2 and 5 in number. So that 5 multiplied with 2, so that positive 10 should be the oxidation state around the central chromium. Expected to be plus 10. But in practice, you can clearly see chromium maximum oxidation state possible will be plus 6 only. If you see this molecular geometry, then only you can clearly explain how can we say it is plus 6 rather than plus 10. So this can be clearly explained by, whenever double bond O is there, this is called carbonylic linkage. Whenever carbonylic linkage is there, this oxygen purely of -2. It will contribute a -2. Always remember, any oxygen under peroxy linkage will contribute -1 rather than -2. So that this is the peroxy oxygen, this is peroxy, this is peroxy, this is 4 peroxy oxygen contribute each negative charge only. So the total negative charge by peroxy oxygens are -4, and this carbonylic oxygen is -2. -4, -2, -6 total negative. So that chromium is accompanied by +6 in order to counterbalance the neutrality, so that chromium +6 will be there. So this is the way we can clear. If geometry is known to you, then only it is possible to assign the proper oxidation state around the central metal. So otherwise we will expect a +10, which is not possible in the practical sense. This is for the question number 3, where you can notice Singly bonded oxygens around the chromium will be 4, right? Move on to question number 4. Again, is the part of JEE Mains 2020 question paper. The structure of the peptide bond is given. This is a lengthy peptide chain is there. You have to see it is the benzene ring with the OH over there. NH2 is there. C double bond NH. This is one peptide linkage, and this is another peptide linkage. This is another peptide. Here is peptide. Here is peptide is there, and free NH2, free COH is there. This is a kind of compound you can take as the reference to solve this problem. So peptide linkages are provided and free NH2OH, NH2COH also noticed. In this peptide, if the absolute values of net charge of peptide pH is equal to 2, pH is equal to 6, pH is equal to 11. So if pH 2, charge, they are asking for net charge. Net charge means overall charge present on this peptide. If pH is equal to 2, what kind of condition you can notice? PH is equal to 6, that is near to neutrality. At that condition, what will be the charge on this peptide bond? And pH is equal to 11. This is a basic in medium. Under basic conditions, what charge you can notice on this? So by using all these charges, so at pH 2, at pH 6, at pH 11, individually you have to calculate their charges. After calculating them, at the final sense, you have to go for net charge. Net charge means combination of all three. All three are nothing but Z1 is the charge of pH 2. Z2 is the charge of pH 6. And Z3 is the charge of pH 11. All to be taken as a sum. That is Z1 plus Z2 plus Z3. So if you are taking this net charge, that is expected to be 5. We need to be calculate 5 to be the final answer, and let's try to reach out how can we get this answer, right? In order to receive that, first let me take the first condition, pH is equal to 2. Being pH is equal to 2, we can say it is acidified condition. Under acidic conditions, it is a protic medium. Acidic condition is nothing but a medium is protic in nature, which releases protons. Whenever protons released, whatever amines are present, these amines will accept the protons. They will be converted into quaternary. That N positive will be generated. So that whenever N positive generated, the charges are raised by how many number? 2 number, because nitrogens only having tendency to accept the H plus ions, and these two nitrogens, though they are present, they're not participating in such a kind of protonation. Why can't we take protons by these nitrogens? Only these free NH2 are accepting H plus. This is very logical in nature. How can we explain this reason? Because this NH is not free bond, rather it is in conjugation with C double bond. But this is called peptide linkage. NH-C double bond is called peptide, and electrons participating, they are very busy with the resonance with these pi bonded electrons. They are in conjugation, right? So that electrons are not free. If electrons are not free, they are not available for protonation. So that we can't say amide linkage is basic in nature to accept the protons. Only the possibility is NH2 and NH2. These amines are free for accepting H plus, and here positive. So that charges obtained, Z1 is said to be 2. Two charges you can notice at the pH level of 2. At pH 2, you can notice this one. So, or this is the kind of acidic medium we can say. If you go for pH is equal to 6, second condition we are discussing about, pH is equal to 6, almost said to be neutral. Neutral means what? How many positive charges are there? That many negative charges are there. All the charges are counterbalanced. We can say positive charges are counterbalanced with the negative charges, so that almost neutral in nature. If neutral in nature, if you want to count the charges over there, that will be 0. How can we say 0? Here positive is there, here positive, here negative, here negative. Positive compensated by negative, positive compensated by negative. Net charge will become 0 over here. And this is the case for what? Second. At pH is equal to 6, nearby neutrality. And case number 3, where pH is equal to 11, which is obviously basic in nature, being above 7 compounds or any components are said to be basic in nature. So that for basic medium is present, acids will be reacted, acids are active towards that, so that both the free acids are losing H plus ions towards the bases, and you can notice carboxylate and NH2 are unaffected, and peptide is also inert in nature, so that only the responsibility for carboxylic acid to release the H plus. So here negative, net charges are 2. For Z3, you can notice the net charges are 2 over here. And one more OH is there. On benzene ring, one more OH, hydroxy is there. That converted into phenoxide after releasing H plus. Carboxylate and O minus. So that you can say it is net charge 3. So for Z1 you calculated as 2, Z2 counterbalanced as 0, and Z3, 1, 2, 3 charges are present. Z3 will be 3. So if you take the sum of all these, 2 plus 0 plus 3, so that net charge will become 5. This is purely dependent upon pH of the solution. Based on the pH, charges will be changed. Positive pH, acidic pH will give reactivity towards bases. Basic pH will give reactivity towards acids. Neutral pH neither reacted with acid or base, so that neutrality we can maintain. For question number 4, 5 is the net charge we can calculate. It's a simple way and important to get a net charge over polypeptide chain. Peptides are the building blocks of proteins. These are made up of amino acid moieties, right? So by this, question number 4 concluded. Move on to question number 5. Which of the following statement does best to describe the Meissner effect? Meissner effect purely related with the physical chemistry domain. And in order to explain about Meissner effect, we have our description over there. We collected some information regarding Meissner effect is expulsion of magnetic field from the superconductor. Superconductor is a kind of material which having maximum extent of conductivity. We can say 100% conduction, 0% resistance are said to be superconductors in nature. And in that case, in that superconductor, now what devices you are using, Meissner effect is clearly explained over there. Whenever any material taken, here it is explained, any material like we are taking a material, copper plates were taken, in that electrons with the opposite spin, electrons are having opposite spin. One is parallel clockwise spin, in either anti-clockwise spin is there. With this opposite spin of electrons, if they are nearby the magnetic field, obviously they get repelled by that one. So magnet, when it is in contact with the electrons which are paired up and with the opposite spins they are located, obviously there will be the kind of repulsions you can notice. This is said to be Meissner effect. That Meissner effect clearly described over there. Electrons are having the kind of, always electrons having a provision to move, provision to rotate. Whenever electron is rotating, there is a kind of sphere generated. That sphere around that electron is called a tiny magnetic field. Always electron having tendency to rotate. During the rotation, a sphere will be generated around the electron, that is called a tiny magnetic field, that related with the electron only, which is generated due to the spinning of electron. Always electron having tendency to spin, and both the ways you can explain that spin. One is positive spin and either negative spin. When this is the case, two electrons are of opposite spin are in contact with the magnet, there is a possibility of such repulsive forces. You can clearly notice repulsions are there. These repulsive forces are clearly explained by the effect called Meissner effect. That is best mentioned in the option number 3. For question number 5, option number 3 will be the correct answer. Move on to question number 6. This is the last question of the session, and it is given from the biphenyls. Biphenyls related with the absolute configuration, right? So in order to assign configuration for the compound, so many methods we have. One is called EZ nomenclature, called geometrical isomerism. A cis-trans isomerism also related with geometrical isomerism. DL configuration, which is related with what, around the last chiral carbon atom, how the hydroxy groups are oriented in accordance with the sodium D line. With respect to that one, with respect to that standard compound, we can notice DL configuration. D compounds will be there, L configurated will be there. And one more kind of configuration we can notice is dextro and levo, that is regarding their rotation, direction of rotation. Dextro levo configuration will be there if any compound rotating clockwise in the plane polarized light, that is called the dextrorotatory. Anti-clockwise is called a levorotatory. So in addition to all this, we have another kind of nomenclature in the stereochemistry. Stereochemistry purely deal with what, orientation, how the molecule is arranged within. So what extent the arrangement of functional groups are present in order to minimize the steric hindrance, and what way it is convenient. That kind of arrangement is purely explained by the stereochemistry. Stereochemistry deals with the arrangement, what position they are occupying, what region they are existing. So that is matter for the stereochemistry. In that stereochemistry, we can go with absolute configuration. Absolute configuration stands for R and S. Okay, R denotes rectus, S denotes sinister. Rectus means what? Higher priority to lower priority. If you are moving, RI moving higher to lower priority, that is in clockwise rotation, is called rectus R configuration. If anti-clockwise rotation we have, that is S configuration. RS configuration is also called as absolute configuration. In order to assign RS configuration or EZ configuration, Carning-Gold rules plays a vital role in order to assign priority for the various functional groups. And it is a typical example. You can notice biphenyl system is there, where you can find SSCH3 called thioether, methyl, aldehyde, bromo. These many functional groups are present. If you observe, one of the benzene ring is on the plane. This darkened part indicates what? This is the way you are seeing the molecule. So this is the direction you are seeing the molecule, which indicates towards the viewer. This part is towards the viewer. Okay, so that's the reason why it is darkened. Wedged bonds, we can indicate them as a wedge bonds. And in either benzene ring indicated in a perpendicular manner. The reason behind this will be, whenever any biphenyl molecule was taken, two benzene rings are planar in nature, and planar molecules can conveniently occupy like this. On the plane, you can place them. But when these two benzene rings are occupied with the substitutions, what happens? They are not comfortable. They are not in the comfortable positions to lay on the plane, so that one of the ring will flip like this, so that whenever flipping of ring is possible, both are said to be perpendicular to each other. Perpendicular to each other is nothing but, so one benzene ring in either benzene ring are in opposite direction. One is laying on the plane, in either opposite to the plane. So this is the way flipping of benzene rings are possible. This is the one laying on the plane. This is the ring perpendicular to the plane, above and below, like this. If both the rings are like this, we can say both are on the same one. But one of the ring is flipping like this, so that biphenyl is represented like this. One is on the plane, one is above and below the plane, right? So this is purely because of, in order to avoid the steric hindrance, they have to be convenient positions to stay, right? That's the reason why. Okay, so in case of this molecule, how can we assign this absolute configuration called R and S? To explain that one, I'm taking a standard example where carboxylic acid nitro carboxylic acid will be there. So let me consider one of the carbon whose functional groups are nitro and carboxylic acid. So one ring to be taken into the consideration first. Okay, at that condition, among carbon and nitrogen whose atomic number is larger, carbon is of atomic number 6, nitrogen is of atomic number 7. Obviously, higher priority can be drawn towards a nitro, and COOH will become B. Higher priority will become A, that is because of atomic number of nitrogen, and this carboxylic acid will become D. In the same case, second one also, in the second compound also higher priority you have to give numbering C, that is NO2 again, so that C, and carboxylic acid again D. So in case of this one, whatever AB are there put on the vertical plane, so in the Fisher projection vertical plane, NO2 will top over here, COH here at the bottom, and whatever C is there can be placed over NO2, carboxylic acid as a COOH. A, B, C, D. If you are moving from A to B, ignoring D, so A to B, if you are moving, this is anti-clockwise rotation said to be S. S for anti-clockwise rotation. This is a standard compound so that we can explain our expected question. So we have SCH3 and CH3. Among carbon and sulfur, obviously sulfur atomic number is higher, 16, carbon is 6 only. So that sulfur we have to give number 1 and CH3 number 2. And aldehyde bromo of higher atomic number, carbon is of lower atomic number. So that 1, 2 like this. After getting this numbering, what happens? SSCH3 can be taken at top and CH3 at bottom, and the third functional group is at this position, bromo is the third functional group, aldehyde is the fourth functional group, like this. 1 to 2, if you are moving again, it is S, it looks like anti-clockwise rotation only. Whenever anti-clockwise rotation is there, you have to assign S, but here is the trick, here is the logic. What you can notice, SSCH3 is inclined towards backside. Here is the dotted line bond. Dotted line bond indicates it is in the backside. So that whatever, after getting the entire configuration, we need to invert this configuration, because the higher priority group laying backside, in order to make it front side, entire configuration will be inverted. S must be converted into R, because SSCH3 is not front side. In the practical sense, it is backside. So that let me mention our configuration. This is the way we can assign numbering our absolute configuration for bicyclic system. This is said to be biphenyl. And this is somewhat informative and really helpful for your solving the problems more, such kind of related problems. If you practice, this will become more familiar for you. And I'm sincerely requesting to like the channel, comment which part is really interesting for you, and share with the aspirants who are seriously preparing. Subscribe the channel to receive more updates. Thank you very much for your patient listening. Thank you one and all.